No, it don't! No, it don't!
0. So yesterday, I taught you how to do limits using graphs. Okay? I'm going to draw a rough sketch. Very, very, very basic rough sketch. Doesn't matter what it is. And let's say this is going to be A. And let's say this is going to be L. And I can say this is going to be f of x. I can say with certainty that the limit as x approaches A for f of x equals to L. Works perfectly fine. But the problem with using the graph technique is this. Look, we're always guessing what that mystery L is. Because if I can, it's all based on a random guess based on your graph. What if I actually give you a more accurate answer? So how can you get a more accurate answer? Can you get a more accurate answer? Because graphing works perfectly fine. Problem with graphing is it's not as accurate. Okay? How can you get a more accurate answer? So I'm going to teach you something called, we're going to use something called limits. Working algebraically with limits. Algebraically with limits. So now we're going to use algebra to solve for limits. Now there's actually 10 laws that they ask you to memorize. 10 limit laws. We're not going to memorize anything. I'm going to just give you a question, we're going to apply it. Because all this time, you're actually applying limit laws without realizing. So instead of categorizing into 10 different things, I'm going to show you how to apply it. After you apply it, when I show you the law, you're going to say, hey, I don't need to remember this because it's actually common sense knowledge. First question. A while back, I started with this limit. X approaches 2 of x. What's my answer? How do you get 2, Manveer?
I just remember doing a problem like this.
Oh, you just remember doing a question like this. Question is, how do you get, is it 2 or is it something else? 2. Find the limit as x approaches 2 of x. Yeah, so let's say do this. If I go limit as x approaches 2 from the left of x, which gives me roughly, I can say, would you agree, it's going to be roughly 2. Because it's going to be 2 point, so it'll be 1.99. If I go limit as x approaches 2 from the right of x, you can get 2.0001. Well, I can say that's going to be roughly 2. So therefore, my limit as x approaches 2 of x equals to 2. I just wasted 2 minutes of my life. I'll never get back. I kid you not. That was just a waste of my time. 2 minutes and gone. In that extra 2 minutes, instead of doing all of this, I could have done something else and saved myself time. What could I have easily done? What could I have easily done? Yeah, it's a very easy concept. Why don't I just plug in 2 for x? It's easily done. I'm going to plug this number here, and the answer is 2. Now, sometimes you must know, why can't we do that for every question? The answer is, you could do that for almost every question, except you didn't. Okay? Some question doesn't work. Some question works perfectly fine. Give you this question. Limit as x approaches 2, x squared plus 2x minus 5. I can waste 2 minutes of my life, and I go as limit approaches 2 from left, limit as approach 2 from the right. But do I really want to do that? Why don't I just go ahead sub in 2? Okay, go ahead, sub it in. So you have 4 plus 4 is 8. So you go 2 squared plus 2 times 2 minus 5. Well, that's simply 3. Easy. If you don't believe me, here's what you're going to do. You're going to find limit as x approaches 2 from the left for x squared plus 2x minus 5. Then you're going to do limit. X approaches 2 from the right. X squared plus 2x minus 5. Take a minute. I'm going to pause it. You're going to do both left side limit, right side limit, and we're going to see if it makes hit our magic number 3. So, they actually did the limit. You should get something around 2.999 something something. If I do from the right, you should get 3.001 something something something. And no matter what, it's going to be hitting almost at 3. Instead of doing left and right side limit, I just save myself a lot of time. It's very simple. Okay? What if I give you a question like this? Sometimes I say, that's easy. Why didn't we do that from day 1? And we would save 3 days of lessons. Limit as x approaches 1 of x squared minus 1 over x minus 1. What happens when I sub in 1? It gets undefined. So therefore, in this case, we got to go back to our old school way. So this is why sometimes I can't sub in 1. See, in this case, x cannot equal to 1. If you sub it in, it fails miserably. It's like done. Kaput kapow. Question?
What if you solve the equation first?
Whoa, what do you mean solve it?
X squared minus 1 becomes x plus 1, x minus 1.
Whoa, not yet, not yet. So, I want you to go left hand limit, right hand limit first. Go, solve it. But potato. If I do the left hand limit as x approaches 1 from the left for x squared minus 1, x minus 1, you should get, was it 1.9999 or something? 1.9999. If I do limit as x approaches 1 from the right, again, we're going to choose any number. You should have 2.0001. And I can, with confidence, say that my limit is 2. Again, that's too much work. So if I go back and look at this question right here, let's analyze this right here. This goes back to grade 11 technique, and this was what Karna was saying. What can I do with this part? No, not yet. Starts with an F. We're going to factor that out. See, x squared minus 1. See, if I really look at this question, and I look at this and say lim, as x approaches 1 of x squared, x minus 1, x plus 1 over x minus 1. See, x minus 1 is gone. So really, this question now becomes limit as x approaches 1 of x plus 1. So now I can sub in 1. So 1 plus 1 really is simply 2. And that's why the answer was 2. I saved myself a lot of time. Why don't you solve this question? Again, try this question right here. X squared plus x minus 20 over x minus 4. A, B, C, or D? Go. Take a minute, solve this question. I'll pause it and let you have some fun with it. I realize x squared plus, so I'm just going to copy down this question in here so we can actually see and work on it. Insert, screen flipping. So if I look at this question right here, I see that this actually becomes x plus 5, x minus 4, over x minus 4. This is gone, so really you're left with x plus 5. Now I'm saying limit as x approaches 4, well, this really becomes 4 plus 5. So the answer is 9. Easy. I didn't even need to think about it. See, the process of limit is pretty easy once you get all the tricks. I don't need to graph because this is as accurate as it gets. What if I give you a bit more challenging question? Try this one. Lim. Again, it's all about tricks. You got to analyze this, see if you can figure out. I'm not going to show you what trick this is, but some of you can figure it out. Lim as h approaches 0 of 3 plus h squared minus 9 over h. The first thing you should always do is ask yourself, can I sub in the value? If you can, your life is easy. If you can't, you got to do something to it. Guys, I'm going to pause it. I'm going to let you try figure. Right off the bat, I know h, guys, can't equal to 0. Because if h equals to 0, it's undefined. Interpol. If I look at here, I can't really factor. So if I expand this out, say, hey, if you can't factor, why don't we try expanding things out? If I expand out the top parts, this bracket, you should have 9 plus 6h plus h squared minus 9 over h. Okay, I just did it because I say I can't factor, so why don't I try expanding? The 9s will cancel out. And what I'm left with is, look, the whole purpose is try to get rid of the h on the bottom. This comes 6 plus h over h. This cancels out. So really what you're left with is lim as h approaches 0 of 6 plus h, and which is 6. No graphs needed, no guessing needed. I did it using pure algebra and math. Okay? And this is as accurate as you can get it. I can make you graph this with a graphing calculator, but your answer will not be accurate. Okay? Why don't I give you a bit more tricky stuff? So I'm going to write a few keys down. I'll summarize it later. This, not everyone can get this. This is the super challenge one. This will be your super no question for today. Good luck. Here is your super no question for today. And I'm going to warn you, it is going to be challenging. Lim as t approaches 9. Actually, I had a dream yesterday that how I'm so mean to you guys. So I decided to give you an easier super no, and I actually had a heart. So I decided to wake up and just give you 9 minus t. I was kind of woke up. I had it bad to say kids were haunting me. 9. Oh please, as if that was that easy. All over. As if I would make it that easy for you guys. 3 minus root t. Woo. Woo. I'm going to pause it. Karen, listen up. Guys, if I look at this question, the question really, if I sub in 9 right off the bat, you get 0 over 0, which can we do? I can't factor this, but I look at this, what gives it away is the square root. And in grade 11, you were taught a technique of how to get rid of the square root. It's called rationalize the denominator. And to do that, this is called the conjugate approach. And in grade 11, your grade should have taught you something called the conjugate. The conjugate really is the whole entire thing on the bottom. So here's what I'm going to do. Copy this down if you're lost. 9 minus t over 3 minus root t times. Here's where the conjugate kicks in. 70. What's the conjugate going to be? Good. See, the only difference is really the sign changes to a plus. So anytime you have a square root, I guarantee you this, there's a good chance it's based on conjugates. It's so darn good. Now we're going to multiply this out. So I'm going to put this side by side and just go ahead and multiply this out. So it'll be 9 minus t times 3 plus root t all over 3 minus root t times 3 plus root t. So when I multiply this out, the bottom, if you FOIL out the bottom, you should have 9 minus t. That's what you have in the bottom. Okay? I want you to take a minute, FOIL the top for me, please. Go. Expand the top. I'm going to pause it and let you. So I'm going to expand the top part. Again, this is foiling. Make sure you do it correctly, please. So this is going to be 27 plus 9 root t minus 3t minus t root t. Okay, that's what you should have. If I look at this question, someone say, what the heck is this? How am I going to solve it? It looks confusing, but you're almost there. I'm going to pause it and let you figure out the trick. This part really is going to dig deep in grade 10 now. We're going back to actually grade 10, where you're taught. I look at the top part, and in top part, you can actually factor the top part. The question is, how in the world do you factor that? And there's a special name of factoring for this. When there's 4 pieces, 1, 2, 3, 4, there's a technique called factor by, starts with a G, grouping. I'm going to show you how this is done. In order for you to factor by grouping, I'm going to write everything side by side. All the root t's on one side, and all the t's on the other side. So this is going to be 27, this is the trick, minus 3t, plus 9 root t minus t root t. Okay, I'm just only going to focus on the top part. See, what I did was I put all the roots together. When I do that, I group them. So now, I'm going to put a bracket around the first 2 terms, a bracket around the next 2 terms. So this is actually grade 10 stuff. Now we're going to go back to grade 10. I'm going to look at the first 2, just look at the first bracket. I see what I can factor out. Well, if I look at this, would you agree you can factor out a 3? So factor out a 3. See, notice I'm not looking at the whole entire 2 bracket. I separate into 2 brackets. So this is 3, 9 minus t. Guys, I want you to look at the second bracket and see what you can factor out. Okay. And Paul, what can you factor in the second bracket? So now I'm going to factor out the root t. How many of you remember this in grade 10, 11, hands up? Factor by grouping? Okay. So this becomes 9 minus t. You see, the moment my 2 brackets are the same, I'm in good shape. So I'm going to factor out that same bracket. So this now becomes 9 minus t, and this becomes 3 plus root t. All over 9 minus t. So this is gone, this is gone. So what I'm really left with is limit as t approaches 9. Hey, look at this. This now is so easy. Say, Mr. That's easy. This really becomes 3 plus 3. Ta-da! And it is based on really 2 techniques. One is called factor by grouping. If you're lost with factor by grouping, I will give you another question for you to practice, because I want you to be sharp with factor by grouping. You're going to use every technique you learn in math to do calculus, and that is why you've been training pre-calc 10 all the way through calculus. So I'm going to pause it, and I'm going to give you another question for you to practice on this, and make sure you can do this. Lim as t approaches 0. T squared plus 9 minus 3 over t squared. Go. Right off the bat, the moment you see a radical, there should be warning bells that you're going to use conjugates. Okay? You're going to try this on your own without my help. Now that I will show you how to do it. You have to use every technique in the book from grade 10 all the way to grade 12 to solve calculus. Again, I'll let you pause it and let you. I see radicals. I'm going to multiply this by a conjugate. Because if I sub in 0, I know it doesn't work. I can't factor for a fact. I can't really do anything. And so my other trick was times. And I'm going to use this technique called the conjugate approach. Plus 3. You know, time flies really fast in calculus for some reason. It's like, it's one of the fastest classes there is plus 3. Key thing I want you to focus on, that's a minus. This is a plus. That's what the conjugate really means. Okay? Here comes the fun part. What the heck is this if I multiply it out? So I'm going to multiply out the top, and before I do, I'm going to put it side by side. It makes it a lot easier for me. T squared plus 9 minus 3. T squared plus 9 plus 3. I warn you guys, calculus is pure algebra. Your algebra skills has to be sharp. So here, again, so I'm putting side by side. It helps a bit. T squared plus 9 plus 3. Here comes the fun part. We're going to FOIL. We're going to expand this bracket with this. And I'm going to just start you off slowly in case you're lost. T squared plus 9 times t squared plus 9, the square root disappears. You're left with t squared plus 9. Then I go plus 3 t squared plus 9. I'm going to stop right there and give you some time to think about this. So now, I'm going to expand out this second part, blue part. Doot, doot. So it would be minus 3 t squared plus 9 minus 9 all over. Now, don't expand out the bottom part yet. I'm just going to leave it the way for now because you never know. Things can cancel out. Okay. I see things that, hey, look, I can cancel a lot of things out. Plus 3 minus 3. That's gone. Plus 9 minus 9. That's gone. So what I'm really left with is t squared over t squared plus 9 minus 3. Is it plus 3? Oh, yeah, it's plus 3. Plus 3, plus 3. And I look and say, hey, look, t squared cancels out again. This is gone. So which means what I really have left on top is 1 over t squared plus 9 plus 3. Look at my work from beginning to end. Now, once I get to here, I can say, hey, look, I can sub in 0 now. Because the whole purpose is to say, I want to get to a point where I can sub in 0. So now when I sub in lim as t approaches 0, okay, 1 over, so this comes root 9 plus 3. And if you did this correctly, it should be really nice. And that's your limit. So the limit as t approaches 0 becomes 1 over 6. It's heavy-duty algebra. So look at my work from beginning to end. I'm going to walk around one more time. If you resume. Once you learn the conjugates, done. So let's go back and I'm going to quickly summarize what we did. Summary. And then I'm going to introduce one quick one and we're done for today. Summary. I started teaching this class with something called limits. As x approaches 0, let's say for something, for f of x. Okay, we'll change this to an a. Most of the time, just sub it in, and you get your answer as f of a. Easy. If you cannot sub in, not sub in a, okay, then try to use one of the tricks below. One of the following tricks. Methods, tricks, whatever you like. 1. We learn how to factor. Because when you factor, you can cross it out. See, if you can't sub it in, then try use one of the tricks. 2. What if I were to expand and simplify? Expand / simplify. Maybe that it will help me out. If that doesn't work, if there's a square root somewhere, maybe I'll try using something called the conjugate approach. Conjugate. If 1, 2, 3 fails, we go with left hand and right hand. But we don't really do that because I'll show you 4, 5, 6 later. There's actually 4, 5, 6 methods. For now, we're going to be stuck with the first three. Factor, expand, and conjugates. Before I can teach you trick number 4, I need to go back to grade 12 and grade 11 about this concept of a BS value. A BS value. Okay. You're the only one who got my joke? Like, must know. It's like a BS value. Symbol for that is this lovely symbol. Everyone probably did this in grade 7. Absolute value of -2. You should be able to give me the answers by looking at it. Rayhan, what's the answer? 2. It turns negatives into positives. That's what we were taught. But in grade 11, your teacher should have taken farther. And if I give you this, absolute value of x equals to 5. What is x? Okay. It could be 5 or -5. So key things I need to write down. Absolute value has 2 cases. Positive case and negative case. You have to learn how to write down properly. So here's how we do the positive case and here's how we do the negative case. If it's a positive case, we leave it the way it is. And we write down x equals to 5. Now, positive case occurs when, this is a crucial part. I need to put a little star beside this. What, if you can do this, you should be fine for absolute value. Occurs when the stuff inside the absolute value is greater than 0. Occurs when x is, see, because x is the only thing inside the absolute value, when that's greater than 0. Negative case. And for you to do negative case, we multiply everything here by a -1. So be negative x equals to 5. And we're going to write down it occurs when, again, everything inside the absolute value is less than 0. You need to know these conditions right here. Highlight this, bubble this, because this is what makes you or breaks you in the next part of limits. And this is the reason why x equals to -5. Easy. I'm going to give you a question. I'm going to walk around. I'm going to help you out so you can solve this. Absolute. 2x minus 3 and absolute equals to 5. Good luck. You have to write down my 2 cases and when it occurs. This is a crucial part, what I'm looking for. A lot of you may be confused. It's okay. I'm going to show you. Don't worry. But I'm going to pause it. So if you're lost, watch what we're going to do. I'm going to do case 1, positive case. Positive case. The positive case is I leave everything the way it is. See? I go 2x minus 3 equals to 5. X equals to 4. But here's where you got to be careful. You got to write down it occurs when. Now here's a trick. Watch what I'm going to do. I'm going to highlight this whole entire thing inside the absolute value. When this whole entire thing is greater than 0. Okay, the positive case only happens when it's greater than 0. Solve for x right now for me. So which is x is greater than 3/2. On your quiz tomorrow, I want to see this, but I also want to see this statement. It occurs when x is greater than 3/2. Using the same logic, I want you to do the negative case with the proper statement. It occurs. You cannot do the next part of it. Here we go. If I do this, I'm going to have case 2 negative. Which means I multiply everything by negative 2x plus 3 equals to 5. And I hear x equals to 1? Negative 1. But what I'm really looking for is, can you actually break this down into it occurs? Now the negative case only occurs when all the stuff inside is less than 0. See, now I'm changing it. It's less than 0. So which means when I solve for it, it occurs when x is less than 3. Oop, what the heck is that? I'm like, what the heck is that? 3 over 2. I'm like, what the heck is going on? Voila! That is it for today. Your